equator, we've already talked about this twice. At the equator, air should rise. When you go to draw this yourself, there's a northern and southern hemisphere. So you're going to start off with two arrows. So you have one going this way and one going that way. So up, up, and then the pattern is down, down. And it's not just like air sinks, but you got to think about the deserts. You got to think about the dry air. And here at 60 degrees, I'm going to have my take gun. I'm going to have rain. And then it sinks back down to the poles where it's dry. Can't make clouds if it's dry. So don't draw this yet. You're going to get to do it in a second. Thank you. So this should be symmetrical. Again, at 30 degrees, air is going to sink. Got to draw two arrows. It's going to rise at 60. And this is where I get, you know, Siberia and the northern part of Canada. That's why they're covered in trees, because there's precipitation to support that. Now you take your arrows and you have to connect them, and it should flow in one direction. So look, here's an arrow going down and there's one going up. So if I draw this, it should flow, and I can check myself. Okay, check yourself before you in fact write yourself. Okay. There's a lot of little checkpoints as you do this. So check me as well to make sure I didn't mess up. And so again, the name of these convection cells, these two here, are the Hadley cells. Hadley, where it's hot. This and this one down here are the Ferrel cells. And then this cell here and the cell at the bottom from 60 to 90 are the polar and the Ferrel. So Ferrel, polar. Okay? What you're going to do at this point is you're only going to look at the convection cell part next to the Earth. All right, so I'm going to start and do one hemisphere at a time. This arrow is trying to go south. Okay, so you got to be the line. It's going to go to the right of its intended direction. So I know I'm drawing it to the left, but you got to be the line. Okay, this one's easier because it gets turned to the right. Okay, and it seems logical. And this one's coming to the south, and it gets turned to the right, so that way. So you name them now. The westerly should come from the west, and they in fact do. And you guys, this is why when we're watching the news and there's a tornado warning, you look at Alabama to see what weather is coming our way. You don't look off into the Atlantic Ocean and wonder if we're going to have a problem with our house getting blown down. The westerlies bring our weather from the west. And this is also why, you know, Britain doesn't have Eskimos and they have Big Ben. This is what causes the Gulf Stream. Okay, I saw some light bulbs there. And this is the polar easterlies, right? They're coming from the east. They're at the poles. Everything's cool. And then these are my trade winds. And they're coming from the northeast. So my northeast trade winds. Okay, as I draw the winds down here, they should be symmetrical. So you can check yourself. All right, this one's trying to come north, but it gets turned to the left. And these are my trade winds as well. But instead of being northeast trade winds, remember we name winds from where they're coming from. So these are my southeast trade winds. This arrow is trying to go south. It's going to get turned to the right of its intended to the left of its intended direction. So you got to be the line. You go that way, right? I need my sheeping to be able to turn my paper upside down. So left. There we go. So these are my westerlies, and they're coming from the west. When you go to do this, I invite you to take your paper and actually turn it upside down. It makes it a lot easier. So here's my polar easterlies, but if I'm looking at them, they're trying to go north, and they're going to get turned to the left. So here's my polar easterlies. And, you know, now check for the northern hemisphere. They match, and these guys match, and these guys match. I've already folded my paper over. All right? So that's it. How do you feel? Cool.